First of all, I welcome one and all in EPG Pachala project of Electronic Science. Friends, this is 11th module of C programming language on pointers and advanced pointers. In this module, we also added multidimensional array. You know, there is a difference between array and multidimensional array. As you know that array can be used for storing similar kind of objects or similar kind of data. This data can be arranged in array by using rows and columns. Whereas pointers are special data types, and pointers are special feature of C language programming. Pointers can be derived from different data type or one of the fundamental data type. You know, there is a difference of pointer and pointer to pointer. Pointer to pointers are advanced pointers. You can use pointers for pointing some data by memory location. You know, pointers cannot be learned by reading books or listening just lecture series on pointers. Pointers can be learned by doing experiments or writing simple programs on computer. I think this module will support beginners of pointer to understand pointers thoroughly and practically. The learning objectives of these modules are to take an overview of multidimensional array, to learn assessing of two-dimensional arrays using pointers, to know about advanced pointers or pointers to pointers, to learn various sample programs on pointers, advanced pointers and multidimensional arrays in this module. Overview. Content of this presentation. Number 1. Introduction to pointers and multidimensional array. Number 2. How to create multidimensional array. Number 3. Assessing two-dimensional array using pointers. Examples on two-dimensional array. Introduction to advanced pointers or pointers to pointers. Function pointers and summary. Overview of multidimensional array. Let us take an overview of multidimensional array. You can think of multidimensional array in different ways in C language. An array is a contiguous block of memory. The two-dimensional array is a really one-dimensional array. Each of elements is itself an array. The number of bytes necessary to hold array A is m by n size of integer number. The element of an array A can be accessed using A x y, where x can be thought of row index and y can be thought of column index. So generally any array can be written as A m into n, where m is row index and n is column index. Array is represented by square bracket A x square bracket y square bracket. Generally arrays are expressed using array expressions like A x y. Let us see how any two-dimensional array can be stored with their elements. In this example, we take an array A with 2 rows and 3 columns. Here we are assuming array A 2 by 3, 2 rows and 3 columns. Our array is integer array because array elements are integers. like integer a 2 by 3 equal to bracket 1 2 3 4 5 6. A two-dimensional array is stored in the memory as follows, like EF20070 is the memory address of first element of array, that is A00, whereas FF20075 is memory address of last element, that is A12, and that element is 6, whereas first element is A00 is 1. Generally, arrays defined like A m by n. M represent number of rows and n represent number of columns. The two-dimensional arrays are represented as contiguous blocks of n blocks and each with size m, which can hold m integers or any data type in each block. The entries are stored in memory as shown above. We can access array element using square bracket operator as AI or using pointer operator, that is star A plus I. Introduction of pointers and multidimensional array. How would you declare pointer variable PTR that can point to a multidimensional array such as A? Such a pointer could be used, for example, in writing a function to deal with A like array. Will the type pointer to integer suffice or enough? Answer will be no. That type is compatible with A0, which points to a single integer. But A is the address of first element, which is an array of two integers. Hence, pointer must point to an array of two integers, not a single integer. This way, you can understand difference between pointer and multidimensional array. Here is what you can do to define pointer. Integer in bracket, star pointer bracket close, and number 3 in square bracket. Pointer points to an array of 3 integer. So meaning of above syntax is pointer points array of 3 different elements. This statement says that pointer is a pointer points to an array of 2 integers. So question comes in mind that why parenthesis needed? Well, square bracket has a higher precedence than multiplication. Therefore, pointer array can be declared as integer star pointer 3. While defining pointer to an array, first we apply square bracket for making pointer an array of 2 integers. Then we apply star for making pointer an array of 2 pointers. Finally, use integer, that is int, making pointer an array of 2 pointers to integer. It creates 2 pointers to single integers, but The original version uses parenthesis to apply. Star first, creating one pointer to an array of two integers. Let us see how to create multidimensional array using pointers. We already studied this topic in array modules. Therefore, we just take an example with sample program to understand multidimensional array using pointer. Let us see the program given on the slide, like include stdio.h, integer main in bracket, integer pointer p, or star p. Next line, p equal to new integer star 3. Then we are using for loop for integer I 0 to I less than 3 plus I. pi equal to new integer 5. You can see in the syntax, like p equal to new integer star 3 is dynamic array, or dynamic array of pointers to integer. Size considered is 3. pi equal to new integer 5. This is written for each ith pointer is now pointing to dynamic array size 10. You can see your p is a pointer, and this p can be considered as p0, p1, p2, p3. In p0 row, you will find total 5 elements like p00, p01, p02, p03, p04. Similarly, you will get p10, p11 up to p14. For p2, the elements are like p20 up to p24. For p3, elements are like p30 to p34. Pointers array can be allocated in physical memory shown in the picture, like p0 to p3, and you can see corresponding pointer elements p00 to p34. The two-dimensional arrays are viewed as an array of one-dimensional array. That is, each row in a two-dimensional array is a one-dimensional array, as we have seen in the figure. Therefore, given two-dimensional array is A array. That is, integer A m by n. M are rows and n column. We can think of A0 as the address of row 0, A1 as address of row 1, and so on. Hence, to find array A 02, we do the following things, like A02 equal to star A0 plus 2. In general, Aij equal to star Ai plus j. Figure shows assessing two-dimensional arrays using pointers. Here we can understand why two-dimensional array is a one-dimensional array in physical memory. You can see A0 and A1. A0, there are 3 elements shown like A00, A01, A02. Whereas A1 includes A10, A11 and A12. Their values are also given, like A00 is 1, A01 is 2, A02 is 3, A10 is 4, A11 is 5 and A12 is 6. We note that A0 equal to star A. Therefore, Aij equal to star Ai plus j equal to double pointer, that is star in bracket star A plus I plus j. Therefore, if A is a two-dimensional array, we can think of A as a pointer to a pointer to an integer value, that is integer star star. A dereference of A or star A gives address of row 0 or A0, and A0 is an integer pointer. The dereference of A0 gives the first entry of A or A00, that is star star A equal to A00. This way you can assess two-dimensional arrays using pointers. In this given example, you can see exact two-dimensional array and their use of array using pointers. As we have seen the difference of variables and array. Single variable stores single element and array stores multiple similar data or similar objects. Now we will see the difference between array and array pointers, or array pointer and array pointer to pointer. If you declare array as a pointer, then compiler allocates sufficient memory to array element. When you declare array as a pointer to pointer, then compiler makes arrangement for reserving some memory location for array pointer. In first case, array includes only element, but when you treat as a array pointer to pointer, then it stores address of array pointer. Now we will see some another example. You can see on the screen there are three variables shown, like pointer p1, pointer p2 and character f. Now for these three variables we considered some memory address. For character f we have memory address 7000. For pointer 2 we have memory address 6000, and for pointer p1 memory address is 1000. Now in this example we can see pointer p2 considered for character f. Character f memory address is 7000. Now there is a relation between pointer p2 and character f. Pointer p2 holds memory address of character f. Memory address of character f is 7000. Therefore p2 as a pointer consists of memory address 7000. Now I am considering pointer p1 for pointer p2. P1 pointer stores memory address of pointer p2, that is 6000. Now your pointer p1 has address 1000, pointer p2 has address 6000, character f has address 7000. If I want to put some relation between pointer p1 to character f, then you can say your pointer p1 is pointer to pointer for character f. So this example will give highlight on difference of pointer and pointer to pointer. Let us see what is pointer to pointer. A pointer to pointer is a form of multiple indirection or a chain of pointers. Normally, a pointer contains address of variable. When we define a pointer to a pointer, the first pointer contains address of second pointer, which points to the location that contains the actual value. The pointers are shown by single asterisk symbol or star symbol before variable name, like star P means P as a pointer, and double asterisk symbol used for double pointer, that is pointer to pointer. Example, star star P, it means P considered as a pointer to pointer. As we know that pointers are little bit difficult to understand for the beginners of C language programmer. But if you understand single pointer, then double pointer can be easily understood. Let us see the difference. Single pointer means star P and double pointer means star star P. The double pointer stores the address of pointer variable. Single pointer stores address of variable. Let us see how double pointers are declared or pointer to pointer declared in C language. This slide explains how double pointers declared in C language. You can see syntax of double pointer. Integer star star PTR to PTR means pointer to pointer. Let us understand example of double pointer. You can see integer number equal to 68. It means variable name is num and value is 68. We are also assuming integer as a single pointer. Integer double pointer, that is PTR to PTR. PTR equal to ampersand num and PTR to PTR equal to ampersand PTR. Meaning of this is pointer stores memory address of variable num, whereas pointer to pointer stores memory address of pointer where num variable is stored. Let us see syntax and respective outputs of the statements in C program or in C language. You can see there are different statements and their corresponding output. So first statement is star PTR, means we are considering pointer, and output will be 68, because in before's example you can see your num equal to 68 and your written like PTR equal to address or ampersand num, and that is the 68. Second statement like star star PTR to PTR, there is also 68. Then PTR is ampersand n, means memory address of number num. Next statement, that is PTR to PTR, is ampersand PTR, means memory address of pointer. Let us see how pointer to pointer can be written in some sample program. This is the example of use of pointer to pointer. You can see program hash include std input output.h integer main. Then body of main program is integer num 68 star ptr double star ptr to ptr, ptr equal to address or ampersand num, ptr to ptr ampersand ptr, printf %d because you are considering ptr to ptr as a integer, %d comma double star ptr to ptr, return 0 because we are assuming main function as an integer. If you run this program, what kind of output you will see? You are printing pointer to pointer, that is double pointer, and result will be 68. Let us see advanced pointers. We have seen pointers, and as you know that pointers can store memory address of variable or memory address of data. We have used pointers in different ways. We have seen there is one-to-one connection between pointers and arrays. How we can treat them alike although they are same in some manner. We have taken a glance on subjects like multidimensional array but have not gone in depth of it. We focus on the complexity of pointers and their advantages in C language. Multidimensional arrays are the first topic to consider. We have looked how to create arrays using array expression, that is square bracket or array bracket. We have seen how to use arrays using array notations and how to use them as a pointers because all arrays are pointers. We have even used arrays which are multidimensional array. We know how to create an array of size x element, say of type character. We can do this by syntax character string 40. This will create an array of 40 characters. This tells the compiler to reserve 40 characters in memory to use for this array. We can also create a dynamic array using memory management functions like malloc, calloc and reallog. These are the memory management functions. We can also use this for creation of dynamic array. But at this point we will not highlight memory management functions in this programming module. Character star string equal to character star malloc bracket 40 size of character. So this is just example given over here. To understand, other functions can be used to declare pointer or use as a pointer. We have also seen how to create an array of strings literals like constant, character, star, str and square bracket equal to string 1, string 2, string 3, string 4 and so on. This last example is a kind of multidimensional array. Remember that arrays are pointers. So an array of pointer is an array of array, and that is exactly like multidimensional array. We can also create array of arrays with numeric values. We have also seen these examples in before's module. We also seen array examples on single dimensional array and multidimensional array. Here we are using multidimensional array for a character. Here characters or strings are like string 1, string 2, string 3 and string 4. For storing these 4 different strings, we are using multidimensional array with pointers. Now you can see the tables. These types of table are helpful to know about array with rows and columns. You can see static, unsigned, short, integer, parts, 4 by 4. Here you can see there are 4 parts, part 1, 2, 3 and 4. Part 1 considered as a memory address for 4 different elements. Part 2 memory address of next 4 elements. Part 3 memory address of next 4 elements. Part 4 memory address of next 4 elements. So in this we have made provision for 16 elements and therefore 16 memory addresses divided into part 1, part 2, part 3 and part 4. First A and second bracket empty, set of numbers are rows, and first empty bracket, second bracket B, set are columns with the rows. The multidimensional array are 2-level complex as it very common because tables are very useful and simple representation of many sets of data, matrices, graphs, maps and grid-like structures. Till here we have learned pointer to data type like character, integer, etc. But in this section we will see about pointers and pointing to pointers or pointers to pointers. As we know that it is special variable that can store address of another variable. Then other variable can very well be a pointer. This means that it is perfectly legal for a pointer to be pointing another pointer. Let us suppose we have a pointer P1 that points another pointer P2 that points some another character. That is also possible. So in pointer to pointer you can treat one pointer for other pointer for next pointer using pointer to pointer concept. Let us see the difference between array and normal variable by pictorial representation. Let us see normal variable. Normal variable means an element or feature or factor that is liable to vary or change. It is non-consistent or having fixed pattern. Whereas in array we get ordered arrangements or systematic arrangement of similar objects. Array is nothing but range of particular type of things. In this picture we can see range of colored objects. This slide tells exact difference of normal variable and array. In normal variable you can see there is single element stored, whereas in array we get collection of similar objects or collection of similar variables. You can see in array we have shown various similar objects or similar kind of objects. Here we have shown circles, ellipse, triangles, etc. in array. Whereas in normal variable, just single element. So you know that array collects several elements and variable stores single element. Variable value can be changed. Let us summarize same picture of pointer to pointer once again. You can see there are two pointers, pointer P1, P2 with memory location 1000 and 6000. Character F for memory location 7000. Pointer P2 considers a pointer for F. Therefore, pointer P2 includes memory address 7000. Pointer P1 considers a pointer for P2. Therefore, P1 stores 6000 as the address of pointer P2. Now, if you want to put relation between P1, P2 and character F, then you can say P2 is pointer for F, P1 is pointer for P2, and P1 is pointer to pointer for character F. Let us see how do we declare P1 and P2 pointer. P1 pointer can be declared as character double star P1 equal to ampersand P2. P1 is a double pointer because pointer to pointer for character. Hence, 2 star or asterisk used in declaration. Next is P2 declaration. Character star P2 equal to ampersand CH for declaring P2 pointer for character F in before's example. Now we can see expected output. We can see P1 is the address of P2, that is 6000. Star P1 is the value held by P2, that is 7000. And double star P1 is the value at 7000 is F. Now P1 and F relation is pointer to pointer, and therefore double star P1 is F. Now we can see one more example on pointer. In this example you can see we are considering pointer P1 as a pointer to pointer, that is null. So characters are null for pointer P1. Then character P2 again null. Character C treated as F. Now in this program you can see P2 is ampersand C, P1 equal to ampersand P2. So your P2 is memory address of C and P1 is memory address of pointer P2. Now we will print out certain variables like printf C, printf pointer P2, printf double pointer P1, return 0. If you execute this program, then you will get some output. But before that we will see these three printf statements. You can see first printf, that is C equal to %C because C is character. Printf star P2 %C \n comma star P2 means you are treating P2 as a pointer, and double star P1, that is pointer to pointer. If you execute this program, you will find result like C equal to F. So your character is F. Star P2 is F because you are considering pointer for character F. Then you are saying pointer P1 means pointer P1 will be P2, correct? Then double pointer P1 means pointer to pointer for character F. Therefore result is star star P1 is F. So your result shows F F F for C star P2 and star star P1. Let us see function pointers. Function pointers are similar to pointer to characters or pointer to integers, etc. We can have pointers to function. Function pointers can be declared as, you can see the syntax, return type function, star name of pointer, type of function argument. You can see the example like integer, star fptr. Fptr is pointer name, and function arguments in this we are considering as an integer. This statement declares a function pointer, that is fptr, that can point to a function whose return type is integer and takes two integers as argument. We will see about function in depth in function module. Function pointer is a type of pointer supported by third generation programming languages and object-oriented programming languages. Instead of referring to data values, a function pointer points to the executable code within memory. This way, you can understand function pointers. Let us conclude this module on multidimensional array, pointers and advanced pointers. In this module, we have seen so many aspects about multidimensional array, pointers and advanced pointers. We have seen how to use multidimensional array, how these elements are accessed, how multidimensional array is declared, along with pointers. In this module, we also highlighted sample programs on pointers and advanced pointers, along with function pointer. I think this module will give a great support to the beginners of learners of pointers and advanced pointers.